Graphs of categorical data. So in this example, we have eye color of 10 newborn babies. 7 had brown eyes, 2 had blue eyes, and 1 had hazel eyes. So eye color is not a number. Brown, blue, and hazel are not a number. So this is a categorical variable. It's not a numerical variable. So our graph is going to, for the scale for eye color is going to be categories instead of numbers. So the categories are brown, blue, and hazel. And the vertical scale is going to be the frequency. Sometimes usually the horizontal scale is the variable, and the vertical is the frequency, but sometimes they switch that. Anyway, I'll do it here with the horizontal scale is the variable. The variable is eye color. So we have 7 babies had brown eyes, and so the bar goes up to 7. 2 had blue eyes, the bar goes up to 2. 1 had hazel eyes, the bar goes up to 1. Okay, so we make a bar, for each, this first one goes up to 1. It goes up to 7. This is for brown eyes. For blue, it goes up to 2. And for hazel, the bar goes up to 1. Okay, so that's our bar graph. Now this looks like it's right skewed, but you don't really talk about symmetry and skewness with categorical variables, because the order of the categories is arbitrary. So these are not numerical, and you could just as easily put brown in the middle. If brown is on the right, if brown is on the left, now it looks like it's right skewed. The longer tail is on the right, but if brown is on the middle, then it's going to look symmetric. If brown is on the right, it'll look left skewed. So we don't usually talk about skewness or symmetry for bar graphs. If the graphs are put in order from the most frequent to less frequent, like we have here, or vice versa, less frequent to more frequent, it's called a Pareto chart. Okay, and we could also do relative frequency, and it's going to be basically the same graph. If we do relative frequency instead of frequency, the total number of babies is 10. So if we divide the variable by 10, we'll get the relative frequency. So 7 had brown eyes. 7 divided by 10 is 0.7. 2 had brown eyes. 2 divided by 10 is 0.2. 1 had hazel eyes. Divided by 10, you get 0.1. So this is basically the same graph we had before. It's just we have relative frequency instead of frequency. You could also do percent. Percent means hundredths. If you multiply each of these numbers by 100, you get the percent. And again, it's basically the same graph. You could also do a pie chart. Pie charts take up space for the amount of information conveyed, so they're not usually used in professional publications, but they might be used in like a newspaper article or something like that, magazine article. So we have 10 babies, so I divided the circle into 10 slices. So each baby gets 1 slice. So we had 7 with brown eyes, so that means that we have 7 slices for the brown-eyed babies. So it's 1, 2, 3, 4, 5, 6, 7. we have seven brown-eyed babies. Okay, and then we have two with blue eyes, so that you get two slices there. And one with hazel eye. Okay, so that's a circle graph or a pie chart. And you could also do the relative frequency. If you divide by 10 babies, divide each by 10, we'll have 1/10, 2/10, and 7/10. So you can do a pie chart using the relative frequencies here. Or you could make it in percent. If you multiply each of these decimals by 100 to make it into a percent, you'll have 10% hazel, 20% blue, 70% brown. And that concludes this presentation.